Hi everybody, in today's tutorial we're going to be looking at a scenario where a ball is bouncing around a canvas. It's computer controlled, and a keyboard controlled paddle is going to be moving up and down on the y-axis, trying to defend the right edge of the canvas. Just to note that the references of x and y for these two shapes is going to be the center of the shape. And the reason I mention that is because often in game design, especially with rectangles, the reference is the top left corner. But in today's tutorial, we will be referencing from the center of the shape. Okay, so let's get started. I've already created my HTML file. I've called it bouncegame.html. I already know where it's stored. I haven't saved it in the downloads folder or some ridiculous place on my computer. I know where to find it, so I'm good to go. So I've already put in the skeleton of the game code. And in the script, I've already identified some global variables. I know that the x and y values of the ball are going to be changing in the game, so I need to store those as variables. I also know that the x and y direction of the ball will be changing because it's bouncing, so I need to store those values in variables. And I also know that the paddle's y coordinate is going to be changing because it's going to be moving up and down the screen. So we need to control that with the help of a variable. I've made calls to the setup and draw function, and now I need to define those two functions. So I've already started with the setup function. In setup, we're going to create a canvas, give it a background color, and give the global variables some starter values. Okay, so hopefully you're familiar with this from previous tutorials. Now let's look at the draw function. The draw function is going to help us do a variety of things. I've listed them as comments just to help me plan my coding. The first thing we're going to do is redraw the background. The second thing we're going to do is draw the ball. It's going to be an ellipse. Its x value is defined by this variable, ball x. Its y value is defined by ball y, and we will give it a width of 20 and a height of 20. Now let's draw the paddle. The paddle is going to be a rectangle. Its x value doesn't change. Its x value, let's make it something like 380. Its x value never changes. It's not moving side to side. It's only moving up and down. So let's give it an x value of 380. A y value of paddle y. This is controlling the y coordinate of the shape. And we also need to give a width and a height. We'll give it a width of 30 and a height of 50. Okay. Oh, I tell you what, do you remember I said that we're going to be referencing these shapes from the center? We need to just tell the program that in our setup function. So the rect mode will be the center. Every rectangle will be referenced from the center, and all of our ellipses will also be referenced from the center. Okay. Now let's move the ball. We're just going to say, okay, the x coordinate of our ball will be updated. So take the current value and add the y direction value, the x direction value, sorry. And we'll do the same for ball y. So hopefully now we've got a moving ball. Let's do a quick save and just go and have a look at our file. Okay, things are working. Now we're going to check for bounce. So if the x value of the ball is less than 0, or the x value is greater than 400, it means we've reached an edge. So we're just going to reverse the x direction of the ball. Okay, and we'll do the same for y. If ball y is less than 0, or ball y is greater than 400, we're going to change the ball y direction. We'll just reverse it by multiplying it by -1. Okay, so let's just save that and see if it works. Boom, boom. So we've got some bouncing. Okay. What do we need to do next? Move the paddle up and down. These are going to be using key codes. So I've already put a bit of code here. So to move the paddle down, we're just going to check if the key is down is key code 40. It means we were pressing the down arrow. And if we're pressing the down arrow, we want to say, okay, paddle y will become paddle y plus a value. Let's just give it +5. Now if I save that very quickly and refresh, and let's test it. Oh, yeah, but it keeps going. It disappears off the canvas. I don't really want that to happen. So I'm only going to do this if paddle y is less than 400 minus half of the height of the paddle. And the height of my paddle is 50. So the bottom of the canvas minus 25. If that's true, we will move the paddle down the screen. So let's just save that and see if the logic works. If you're not good at maths, you might need to think about that a little bit. There you go, bingo, perfect. So I'll need to think of similar logic for the up. Okay, we're going to say paddle y equals the current value of paddle y minus 5. But we're only going to do that if a condition is true. So you see if you can code that bit, okay, to keep the paddle from going off the top of the screen. Okay, I'm going to leave that to you. Now we're going to check for a collision. So we know that we can calculate the distance between two objects by using the dist formula. Ooh, I have a new variable here, distance, so I'm just going to add that to my list of global variables. Okay. So it's going to be the center of the ball, which is ball x, ball y, the distance from the center of the ball to the center of the rectangle. Now remember, the paddle's x is 380. It never changes. And the paddle's y is defined by this variable. Okay. Now if the distance minus the radius of the ball, well, the ball's radius is 10, minus the width of the rectangle, well, the rectangle's width is 30, so half of that is 15. If that value, let's just wrap that calculation in brackets, if that is less than or equal to 0, it means we collided. So we want the ball to go back on the x direction. So we're going to reverse the x direction of the ball. So let's save that and see if this works. Oh, let's give it a moment to come back. Are we going to get it? Am I any good at this game? Yeah, okay. So we've got bouncing off everything. That's brilliant. Now we're just going to finish today by looking at one more cool aspect of programming. Our draw function is becoming very complicated. Lots of lines of code here are doing important things and very specific things. Okay, so when we draw the ball, wouldn't it be great if I could do this? Just call a function called drawBall. Okay, and all that function does is this line of code. In fact, I'm going to cut that code. I'm going to go down here, outside of the draw function, that's end of draw function. I'm going to define my own function called drawBall. So drawBall just does that. When we call the function, it just does that. So we call it here, and it jumps down to the function, it finds the function, there it is, and then it does the thing that the function is supposed to do. We are calling a function. Let's just save that and see if it worked. Yes, everything still works. Let's go back to our code. DrawPaddle. I'm going to call a function called DrawPaddle. And I'm going to take my DrawPaddle code, which is there, and I'm going to design a new function called DrawPaddle. That's the DrawPaddle function. That's all it does. So we've got two new functions here, DrawBall and DrawPaddle. MoveBall. Okay, I'm going to define a function called MoveBall. I'm going to call it here, and I'm going to define it down here. So when we move the ball, this is what we do. So in our draw function, we call the MoveBall function. We call it. When we reach this line, it jumps down, it finds the MoveBall function, and it does the MoveBall code. Okay? So can you create some functions which will check bounce, move paddle, and check for collision? Okay? Have a go.